Okay. Hello, everyone. Welcome to my first stream of the year. And in today's stream, we are going chatting about Python and DevOps. He is Shivay. Shivay, please introduce yourself.
Yeah, hey everyone, I'm Shivay. I'm super excited to be here. So I've had the honor to be on Sophia's stream before as well, and like she's doing some amazing work with DevRel and Python, and used to work together at Pieces in 2023. So it was a great time, and of course, primarily I have been a machine learning slash DevOps engineer. When I was doing full time software engineering, and like last 3 years I've been doing a lot of DevRel as well, primarily working with AI companies. So right now I'm working closely with a couple of other folks who were with me at Pieces with Arindam and Amitesh building Studio One, which is DevRel consultancy. So yeah, super excited to be talking today about Python and DevOps.
So, same here. And for everyone that is joining, thank you very much for joining on this stream. And Big Sam, first viewer, thank you very much for coming over here. Okay, so Shivay, I'm gonna start this conversation off with a very, very simple question. So, what exactly is DevOps? Now, I know that there's some people watching that may not have heard of DevOps before. So, what
Yeah.
is DevOps?
Mhm. Yeah, I think before we even speak about DevOps, if we just look at from a very basic understanding of how software is written. So, of course, you'll kick off your project with installing the dependencies, and then you will go ahead and write your APIs. And if you have a front end, then you'll write the front end and you will do the testing of your project locally. Now, of course, now if you want to serve it to everyone in the world to be able to use it, you need some sort of a methodology. And typically, that method would be that either you can self-host that entire software server code on your local system and make your local system act as a dedicated server, so that anyone on the internet now can access a particular IP address, or for that matter like a dedicated URL, and they can access that particular tool. So of course, this kind of kicked off the entire idea of being able to serve software so that anyone across the internet can basically access it. Started off with people trying to run these large scale applications locally on their systems, but from there we saw that there is rise of VMs, virtual machines, and then containers. So all of these are what we kind of say as part of DevOps. But what does DevOps itself mean? It basically means developer operations, which essentially understanding is that okay, you have, as your software engineer, you have written your software, but now it has to be deployed somewhere. It has to be served somewhere so that hundreds and thousands of people can actually leverage it, right? Or even if it's not a
Okay.
production grade application, you are probably creating an app internally for your company's use case. So you still need a dedicated resource where you can run that application code and then serve it to everyone else, right? So these are the main guiding principles of developer operations. If you ever come across and see one of the diagrams of DevOps, you'll see that you have the software engineers writing the code, but then the role of the DevOps engineers is to now take that code, test it, ensure that it builds properly, and then serve it somewhere. Now that serving could be on a on-prem server, server rack, or it could be in the cloud. So of course we can probably dive deeper into all of that, but I know like today is not just about DevOps, but we
Yeah.
can probably spend like 3-4 hours just talking about DevOps. But yeah, that's the crux of DevOps, right? That how do you automate and how do you make your application code that you're writing into production, whether it's on the cloud or not on the cloud, and make it accessible and scalable at the same time. So, and
Oh,
then
I
ensuring
see.
that ensuring that your application also scales, because you want to build an app like Amazon during the big during the Black Friday day sale. So you need to make it scalable so that it can serve like millions of the requests at the same time. Or it's just being able to automate the creation of the environment where you will basically run your application code. Even that is part of DevOps. So anything that's operationally heavy, which is responsible for taking that application code that the software developer has written, that's running locally into their system to make it accessible, uh, is the role of a DevOps engineer. So it's a very important role today because most companies are having now a SaaS product offering. So that means that they want to scale it and they want it to be accessible by thousands of hundreds and thousands of users. So DevOps as a profession has really grown in the last like 15-20 years.
Oh wow. So the very first time I heard of DevOps, I thought it's like something that a backend developer or a backend engineer should know about, or something that they handle. Because
Mm.
I think two years ago, when I was working as a backend engineer for a startup here in Nigeria, I came across I think a course that had to do with something about automating the development pipeline. And in my head, I'm like, okay, so that's
Mm.
DevOps. And then 2 3 years down the line, I found out that DevOps is actually an independent field.
Yeah.
And yeah, so this is really really nice to
Yeah,
hear.
and I think so. You're absolutely correct in saying that it is an independent field as such, and you can just be a DevOps engineer. But today, most of the backend development roles they require you to have at least some sort of knowledge of DevOps. You don't need to
Yeah.
be a certified AWS practitioner, but you still need to learn about things like containerization. That you have written your application code, but how do you actually test it? So as a backend engineer today, if you don't have knowledge of Git, you don't have knowledge of Kubernetes, Docker, then your chances of getting selected for a job role might be affected, because we have transitioned away from just writing APIs and defining models and controllers and doing CRUD operations on databases to now backend being very much centered towards also being able to deploy applications. And that also
Yeah,
actually goes for front end engineers as well, right? You have so many front end friendly DevOps tools. If you look at Vercel, Vercel is all about being able to take your Next.js or any other front end library code and being able to deploy it, being able to add secrets, being able to look at logs of how your front end app gets built and developed. Because as the application frameworks also get more complex, they introduce a lot of dependencies that do not make it as simple as just a simple HTML and CSS page that you can just up you can basically serve an up and make it running. Even like for example, even if you don't want to, even if you want to make a static HTML site visible, you need some sort of a development server to be able to serve it, and that could be through
that's
Nginx.
true.
So that is why I think DevOps is something that every software engineer, whether it's a front end, full stack, back end engineer, should know today. It's becoming a must. Similar to how today with AI, we all of us should learn how to use prompt engineering better to be able to become more productive. I think as a software engineer, DevOps is really really important. So
That's true.
students who are learning computer science and they're building projects should probably take one step ahead and also try to deploy their projects and learn through that cycle of what is software testing, what is how to properly build your software, how to learn tools like CI/CD that can automate the deployment of the project, because those are becoming, I would say, essential part of the job requirements of a core
Yeah.
backend engineer as well.
Yeah, that's 100% true. So how do you think that Python relates to DevOps?
Yeah, I think so. As I mentioned, right, that if you look at the life cycle of any DevOps project, so if you understand like what's the roadmap of learning DevOps, what are the key components of DevOps? So of course, we always say that we start off with
Okay.
Linux or Bash commands. So of course, Linux as a system is the most widely adopted way to be able to deploy any software on top of a Linux system, because of its dependencies, and most of the servers are running Linux based systems. Then you need things like computer networking, computer operating systems, because these help you to understand how IP networks work. So all of that is also required. Then there are, I would say, like four different other streams of DevOps. So starting off with CI/CD, which is continuous integration, continuous deployment, which is primarily used for being able to like take your application code and automatically deploying it, being able to get the latest production version of the app based on a Git push that you make to a GitHub repository. So you can basically spin up these automated pipelines. This could be a GitHub action, it could be a Jenkins pipeline that you run. Then you have containerization, which means that you're taking your application code and you're no longer just running it on a VM, but you're also dockerizing it and then serving it inside of Docker Hub. And then you can go deeper into Kubernetes, which is primarily for orchestrating all of your containers. But then there are like different other branches of DevOps, such as Terraform and cloud automation, where if you're trying to have a bunch of cloud resources, and rather than manually creating all those resources, you want a way to programmatically do that, you can leverage open source projects like Terraform. So always, obviously, there are all these different branches, and then I've not even dive in, or have not dove into like observability and monitoring. Like that's another side of DevOps, right? Again, this stream is not
Okay.
for DevOps, but Python plays an important role, right? So Python, I would say, like, there are, you can think of it in three ways. One is that us as software engineers, we don't want to write a lot of YAML. So YAML, by the way, is the format in which you mostly define your scripts or your containers, right? So if you're like, for example,
Yeah.
creating a Kubernetes cluster, you'll have a deployment YAML, which will be used for deployment of the resources. And then you'll have a services.yaml, which allows you to basically manage the network connection between the different pods in your Kubernetes ecosystem. And most of these are YAML. While so YAML is very similar to JSON, so you don't have to. If you know how to write JSON, then YAML should not be a very difficult task to pick up. But some developers, they want the ability to not have to leave their favorite programming language, and that's the reason that there are a lot of open source tools today that allow you to actually write your entire CI/CD pipelines or your YAML files directly in your favorite programming language. So it could be an
Okay.
SDK in JavaScript, in Java, in Python. So of course, you see adoption of Python as a way through SDKs, where your popular DevOps tools, technically you can use YAML or JSON or shell scripts to be able to run and execute those DevOps tools. But if someone wants to do it programmatically and with the help of a programming language, they have SDK support in multiple languages. So I would say like that's one pillar of how you leverage Python. And I'll be more than happy to share a couple of examples for the first
Oh
part,
yeah,
which is,
please.
yeah, yeah, absolutely. So let me go ahead and share my screen. Give me 1 second.
All right. Okay. So while you share your screen, if you have any question relating to DevOps or Python in DevOps, do well to leave them in the comments, and Shivay would answer them.
Yeah. So I've just shared my screen right now. Now, the first one that I would like to probably also touch upon is a project called as Dagger. So Dagger, let me probably just open up dagger.io. So, oh, yeah, perfect. So, the idea over here is that, we were talking about your typical CI/CD pipelines. Now, if you look at something like a GitHub action, um,
Okay.
mostly you're basically writing the GitHub actions as .yaml files, right? So if you look at an example of a typical GitHub action, this particular file, which like is, the action is on push, you're writing YAML. Now, not everyone might probably want to write this. Okay, if it's a one-off script, then it's fine. But if you're having hundreds of different microservices in your company and you have a lot of different tooling, and you have to essentially write multiple YAML files, some developers might not actually like it. So that is why you have the ability to write or define your entire pipeline code inside of Golang, TypeScript, or Python. So one such example is Dagger. And in fact, like, the company was co-founded by the same person who created Docker, Kyle.
Wow.
I hope I'm pronouncing his name correctly. So Kyle, who was the co-founder of, or who co-created the Docker project, left Docker and then later began to and started to build Dagger, right? So here, for example, now if I'll just quickly show you an example of Dagger. So here I have a Dagger workflow that I have basically defined, and here what you're seeing is that the idea over here is, and basically this is borrowed from a project that I wanted to, I'll just quickly also show you, which was like how do you build an MLOps pipeline with the help of Dagger. So
Okay.
here, technically, you could have written a dedicated a dedicated uh, YAML file where you would have
Yeah.
probably pushed your ML model to a production with the help of YAML. But here we are taking all of those abstractions of a YAML and wrapping it around with this open source project called as GitOps. So with the help of Dagger. So here, what you're seeing is that we have, this particular example over here in the main.py, where you can see that in this case we are using an open source project called as GitOps, which allows you to efficiently package your machine learning models and your machine learning projects inside of container like images. So it's very similar to
Okay.
how like you package your application code that you might have written. So like taking example of, like, let's say if I go back probably to this example, so here you'll see that I have like this Flask app, right? So a normal use case would be that you take a Python app, and or any other language app for that matter. So you have a Python function. This is a simple Flask API, and then you create a Docker file out of that where you define the base image and the requirements, and then you go ahead and execute that particular application code. So this is a typical example of containerizing an entire app inside of a particular language. So in this case, like, we are taking example of a Flask app that will containerize, and then we can deploy this container on any other OCI compliant registry, whether it's like Docker Hub or any private registry as well for that matter. So this is like a traditional example of how you can package your application code written in Python, right? Which is like the first step towards getting into DevOps, which is like even
Okay.
before we think about Python, we are talking about how do you uh, leverage DevOps to make your application code in production. So in this case, what this particular application is doing is that it has an endpoint of predict, where it does sentiment analysis on the type of text that you send to it. So that is why if I open up the let's see if I have my Postman running. So here, I'm basically going to be showing that. So the idea over here is that we can leverage this particular tool. Now, going back to what I wanted to quickly show with GitOps. So the idea over here is that GitOps is a project that allows you to package the different components of your machine learning system, and I'll make sure to also just cover that. So it's called as GitOps.ml. So it's a tool
Okay.
that allows you to very easily deploy different parts of the machine learning system as one single package. And similar to how in containerization we have something called as like a Docker image or an image, right? Similarly, GitOps has something called as a model kit, so the idea over here is that a model kit can basically package together all of the different core components of a system, such as your model itself, the notebooks and the data sets, and any other relevant documentation that you might have. All of that can be packaged together into this one format, and then you can deploy it on any OCI compliant registry. So whether it is with the help of Docker or in Docker Hub or any other private registry, where you're basically deploying your typical container workloads. You can also deploy similarly you can also deploy your AI workloads and not have to worry about having to use multiple types of tools, such as using a S3 bucket for your model, or a data lake for your data set, or GitHub for your code, right? All of that can be packaged together efficiently with the help of GitOps. So
Okay.
going back to the dagger side of things, right? So here, essentially, what we are doing is, and let me see if I'm on the correct. Okay, I think I'm not on the correct. Uh, Let me go back to that. Okay, I might have lost. Okay, perfect. My bad. Yeah. So in this case, what you're seeing is that we are using Dagger, right? So as I mentioned, that if you
Yeah.
don't want to write some kind of a CI/CD tool in YAML, you can basically write all of that with the help of um, Python. So in this case, what you're seeing is that we have defined functions where, for example, if you wanted to make a push to let's say GitHub, you're basically defining a function to actually do that instead of writing the push step, right? So of course, in a classical CI/CD pipeline, you have different steps involved in a defining your GitHub action. So here you're replacing all of that and just writing pure Pythonic functions that allow or make you capable to be able to do so with the help of pure Python, right? So that's like one
Yeah.
example. Now, another example of that is that I told about GitOps, right? So
Yeah.
GitOps allows you to very easily package together your application code. Now, you can, in theory, leverage something called as the Git CLI. So if you just use the Git command line, this is what allows you to manage your all of the deployment of your models, and serving them as package containers. With the help of the Kit CLI, but now they also have, like, for example, they very recently announced a Python SDK, right? So going back to that first pillar of having the SDKs available to you in Python so that you can still leverage the Python language. So a typical way in which you will package together all of your code would be that you would use something like the Git pack command. So a git pack command is very similar to like a docker build command. So how in docker build you need to have a docker file, and that will take up all of your application code and package it into the container image. Similarly, when you use the model git pack um, or git pack command, it will take the git file, which is similar to like a docker file, and then it will generate the actual um, model kit itself that now you can use. So instead of using all of that in command line, you can technically then use Python. So here I'm using the Python SDK for GitOps, right? Where I import GitOps, and then here what I'm doing is that I'm creating a new Git file, and so rather than manually creating it myself, which I could have also done through the terminal. So if I show you, if I just go back over here one step, you can see over here that I have a Git file, right? So I can
Yeah.
show you the content of this Git file. So in this case, like, I'm packaging together this Qwen 2 large language model, and I'm also like taking not just the model, but I'm packaging it with the README and the dataset as well. So rather than defining like a dedicated Git file, which is again a YAML structure, I can do all of that with the help of Python. So here, if you look at the comparison, I think like this will be a good way to showcase the comparison over here. Let me close this window. Okay. So if you just compare the YAML versus the YAML that I've written for the Git file, you can see over here I've defined the package, I've defined the model, I've defined the code. Whereas, and let me bring up this backup. Yeah. And now you can see that I'm just doing it in a Pythonic sense by using the manifest file, defining what my package will be inside of my Git file, what my model would be, what will my part of the code would be, right? So essentially, when I execute this, this will create the Git file for me locally. So I don't have to go along the lens of having to write custom YAML. I can do all of that in Python itself, right? So that's the main logic over here. And then it basically has inbuilt command, for example, to pack and push this particular model kit directly to the registry. I don't have to use separate commands like git pack, and then I don't have to use git push separately, all of those separately. I can manage all of them
Wow.
via writing it in Python. So like, these are the two examples that I wanted to quickly show to everyone, which is talking about the first step, which is how you can leverage Python to be able to automate tasks that would probably have been manual or might have to be written in YAML. Of course, I spoke about Dagger, but then there is another tool called as Pulumi. So Pulumi is also an open source code where you can basically write infrastructure in any coding language. So we spoke about Terraform and how you can basically automate creation of your of your entire DevOps architecture, right? Whether it's like
Yeah.
automatic provisioning of a Kubernetes cluster or an automated provisioning of a VM, right? So typically you'll have to write .tf files. So if you look at a Terraform example, a typical Terraform example over here, right? I'll just quickly show it to you. So I think, yeah, we can just refer to the Terraform examples over here. So normally, for example, if you want to deploy your entire architecture on AWS, so there's this dedicated, like let's say it should be a cron job. So you have all of these .tf files. So Terraform has its own um, language in which
File
you provision the
extension.
cluster. Yeah, its own file extension. That would be a better way to put
Yeah.
it out. And here, if you look at things like, again, we'll not go too deep into it, but you see over here that essentially what we are trying to do is that we are trying to deploy an AWS Lambda function, which is a serverless function, and we are defining all of the core components. So rather than a DevOps engineer manually logging into the AWS cluster, AWS account via the UI and having to
Yeah.
manually set up everything up, you can just define this Terraform file and apply it, and then it will do it for you. But Purumi says that, why even the need to again learn Terraform? When you can do that with the help of Python, right, or with the help of a language. So they allow you to automate your infrastructure provisioning, but with the help of pure programming language. So again, like, they're not just limited in um, Python. They have support for multiple languages. So if we specifically look at their Python example over here, so they have again a dedicated SDK for Python. And here, so you can see that in this case, we are showing two different ways of creating an ECR repository. So ECR is a container registry inside of AWS. So here you can see that they import Pulumi AWS, and then it's as simple as just defining your the first repository, aws.ecr repository, and all of the different things. So now it reduces the complexity of having to learn something like uh, YAML or Terraform, whereas you
Yeah.
can just write all of that in Python itself. So I think, like, that's one of the main kind of pillars where you are using Python as a means to be able to make it easier for development teams to then incorporate practices of DevOps, whether it's infrastructure with Pulumi, or it is something like Dagger for automation of your pipelines, whether it's like CI/CD pipelines, workflow automation. All of that can be managed programmatically with the help of various programming languages. But like, since today's stream is about Python, we are specifically talking about Python. So that's like the
All right.
first pillar. I know I went on rambling for the past like 20 minutes. So if you had
Oh
any
no.
questions, I'll probably pause for a minute and let you speak.
Yes, yes, yes. So I do have a question. So
Mhm.
when you were talking about Polomi, now I just had a thought. I know that I've come across some DevOps job description where it says that you need to like the company uses Terraform.
Yeah.
So when a newbie is learning DevOps, would you advise that they learn Terraform and Pulumi, or focus on Terraform? Then if the company uses Pulumi, they can learn that.
Yeah, I think that's a good question. So it ultimately depends on a team, right? The reason why tools like Dagger and Pulumi were created in the first place was to improve the developer experience when building DevOps pipelines. Now, of course, because DevOps can be very complex, even setting up a single VM, it requires a number of steps. You have to
Yeah.
set up the actual cluster itself. You need to understand what would be the networks, right? You have to define a bunch of different things in order to just have a single working instance of a virtual machine. So that's the reason that we came up with Terraform in the first place. And Terraform will probably be the number one choice for most companies. I think when you talk about like Dagger or Pulumi, they are good to have, but they are not necessary, right? They are important for
Yeah.
development teams who are perhaps lean. So, for example, it could be a young startup, and most of their team has Python experts. So rather than hiring someone full time for managing YAML, they could perhaps just use this particular tool and just write all of that programmatically and not have to learn or have a different team member who is just managing DevOps. So it's a good use case, but I think on a fundamental level, everyone should try to learn Terraform
Terraform.
and probably some other open source alternative to Terraform like OpenTofu, which are the core components of infrastructure as code. So learning like Dagger and Pulumi are great, but the number of jobs that you'll get where you'll leverage them will be far less in comparison to jobs where you'll have to implement your entire infrastructure with Terraform. Now, of course, you can probably showcase business value to your engineering leaders that it's better to probably adopt one of these other open source tools which allow you to programmatically define all of that, but usually it's not a very big of a concern for teams. Like they are completely fine writing YAMLs and Terraforms, so that is why they might not adopt something like Dagger or Pulumi. But at the same time, something like Terraform, all these have been in the industry or in the ecosystem for like 5-10 years, whereas these
Yeah.
tools like Pulumi and Dagger, they're still relatively new into the development ecosystem, right? So teams that value time, right, and they might have limited resources, then yes, it's good to try it out. But fundamentally, you need to understand that how infrastructure as code works, and there I think having good knowledge of Terraform is absolutely necessary.
Ah, I see. I see. So, what other tools can one learn if they decide to venture into DevOps?
Yeah, so of course, like as I mentioned, that that's like the first pillar, but then the second pillar is where you can directly leverage Python for DevOps, right? So we spoke about how you use Python programming language to be able to provision stuff, right? Whether it's provisioning
Yeah.
your CI/CD pipelines or your infrastructure as code. That's of course one aspect of it, but then a lot of cloud automation is happening with the help of Python, and Python is great language for cloud automation. So you can, for example, define serverless functions inside of your AWS Lambda in Python, and mostly people are writing Python or JavaScript for doing that. Or, for example, if you have not earlier heard of Ansible, so Ansible is a tool that came out even before Terraform, which allows you to go ahead and provision hardware and software. And the underlying APIs that you use with Ansible are all written in Python, right? And then if you're, for example, using something like AWS Stack, then the Boto 3 library in Python is an excellent example of Python usage for cloud automation, because it extensively uses the Python modules for any AWS cloud related automations or scripts that you're writing. So, like, one of the key components when we are dealing with DevOps is you typically end up writing a lot of shell scripting. So if you understand, like, what is a shell script, right? So it's a background script that runs during either, like, let's say the first time that your virtual machine spins up. So if you want to do
Okay.
some pre-configuration in your virtual machine, or perhaps you want to do it after you have executed something in your virtual machine, those shell scripts are really great. Now, yes, you can either write shell script, or you can also write Python scripts that can do some sort of an automation for you, because Python scripts have always been great for being able to do like quick automation as compared to any other language for that matter. So whether you're dealing with something related to the CLI, or you want to automate, like, let's say deployment of, or automate perhaps some sort of an API, you can always use these scripts, and these scripts play a very important role in DevOps, right? So I think, like, that's the second key aspect of Python, because again, Python as a language for cloud automation is extremely important, right? Of course, we spoke about infrastructure provisioning, but right now I'm just
Yeah.
talking about that. Okay, you already have your cloud infrastructure built in. Now there are so many different areas where you might want to use some sort of an scripting that might be required, whether it's like doing some kind of a task based on something that you're doing in your cloud environment, and Python is the number one go-to language for that.
I see. Wow, that's awesome. Okay, so you talked about infrastructure, and earlier in our chat, you also made mention of infrastructure as a code. So, does that relate to DevOps, or is that DevOps?
So I think pure infrastructure as code would probably be core DevOps because if you now see that, okay, I mentioned earlier that both a backend engineer and a core DevOps engineer, both of them need to learn about like containers and probably
Yeah,
Kubernetes. But where the role of the backend engineer might probably close in is that yes, they have successfully been able to package together their code and now they have gone ahead and deployed it. Where the core role of a DevOps engineer kicks in is that okay, now these systems are in production. They want to continuously monitor it. So monitoring observability and ensuring that all of the APIs that are consistently being hitting, like there's no blockage in terms of these APIs. Understanding how are the underlying systems behaving, because sometimes what you might see is that when there is a lot of traffic coming to a website, the website server just crashes because it
yeah,
cannot handle that kind of load. So things like load balancing and being able to ensure that your application is resistant to millions of requests coming at the same time, like that's where core DevOps will come into picture. And your traditional software engineer at a big company might not be responsible for provisioning of a dedicated hardware, right? That might be required for a app, for a software project, because like bigger companies, they have a dedicated DevOps infrastructure team, right? They have SREs, which are the system reliability engineers, which comes under the umbrella of DevOps. So I would say like
yeah.
purely infrastructure would still be part of like core DevOps. But even
Okay.
as like a DevOps engineer, if you know Python, then it makes your life much easier, right? So for example, like let's say you want, as a DevOps engineer, you are responsible for migrating the database from one database to another database. So of course, you could do it manually, but you could also write that logic in Python and do it for you, right?
Okay.
So like right now I'm specifically targeting the DevOps persona, where someone who is like purely working on the DevOps part, right, of the company, whether it's like infrastructure or it's CI/CD, or it's doing all of the uh, VM management, all of those, right? So learning Python for being able to build quick scripts that allow you to do things like migrations or apply some sort of settings, like that goes a long way to be able to make you more productive. Because generally, like there is this consensus in DevOps engineers that hey, like we are not writing any code, we are not actually writing the API, so why
Yeah,
even learning a programming language? Like I can just do a bunch of cloud or DevOps courses and learn YAML and I'm good to go. Like okay, as an average DevOps engineer, that's fine. But if you're a good DevOps engineer, you need to learn about probably even like data structure algorithms, probably to not a deep level as a software engineer, but like
yeah,
understand basic programming languages and be able to like quickly, because like if you do certain things manually, it might take you 5 times more time than you could just simply automate something with the help of a Python script for yourself, right? And you don't want to basically waste time of your software engineering team to help you write that script. You should be capable enough to be able to write that script and do it for you, right? So
ah,
these scripts play a very very important role. Like I'm not diving right now into like a very complex architecture, but just imagine then where you have probably hundreds of different DevOps services that you're running together. All of them are interconnected with each other. I mean, of course, you will first scratch your head that okay, how can I do certain? These scripts
yeah,
make your life easier. So and then of course I spoke about Ansible with like automation. And then most of the times, like when you're writing any sort of serverless function, you're mostly going to choose either JavaScript or Python. I think Python is probably a bit more performant. So if you have specific tasks that require multi-threading, then Python is your go-to language, because you can leverage the better like I would say like JavaScript is also great, but it is probably a bit less performant for especially like multi-threaded tasks, because as we know, like JavaScript is single threaded, right? So any sort of task where you have to execute multiple workflows. You can define your Lambda functions with Python, or any serverless function for that matter, and use Python with that. So I think those that is also like another important aspect of Python for DevOps.
Wow. So I just learned that scripting is very important in the DevOps world.
It
This
is,
is something that's,
yeah,
yeah,
both shell
it's
scripting
something
and
that
then
I did not
yeah.
know.
Mhm. So, like someone who is wanting to be a good DevOps engineer, they should have, like, Linux commands and shell scripting on the tip of their fingers. Like they should be able to, if someone tells them that, hey, I'm getting some sort of an issue trying to deploy my application on this, Linux virtual machine, they should be able to very quickly find out what's the issue by using Linux commands. And then if some development team tells them that, hey, I want some sort of automation happening on my VM for my code, then you'll most likely be writing either a Python script or a shell script. So that's what makes good DevOps engineers.
Oh wow. So do you have like any course recommendation on shell scripting? Because I knew that if you want to go into DevOps, you need to know Linux, but
Yeah.
I do not really know much on shell scripting.
Yeah, absolutely. So I'm not sure if there is any, like, I'm not entirely sure about a good video course, but I can for sure share uh, one of these courses that I was responsible for creating. So shell scripting. Let me just see if I'm able to get that. So it's basically an entire DevOps tutorial. I was
Okay.
responsible for basically like defining all of that, but here you can probably take a look at this particular code. I'll just share this in the private chat.
All
So
right.
um, and then like there is a dedicated bash scripting in Linux. So these are like the ones that I'll probably recommend. And this will be the probably like the final link. So shell scripting specifically for DevOps. So these should give you at least like a good idea on how to get started. Of course, there are different things that you can do with the shell script. So the most good one would be this deploy your own VM and try to run it, and create a shell script and try to execute that shell script upon the initial load of your virtual machines. Like that's a good way to start.
Oh, that's awesome, and this is very, 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 very resourceful. I think this is one of the reason why I do this live chat, because every time I go live with someone, I get to learn a new thing. And
Hmm.
now I just learned that shell scripting is very important. So now in DevOps, what are some best practices that DevOps engineers they take, or people that are currently learning in DevOps should take note of?
So in terms of best practices, I think it's really important to consider, because of course, like this will probably be a very broad answer, and I don't want to bore the audience with a long monologue again. But I would say that depending on the kind of role that you're playing in your DevOps team, it will vary from team to team, because again, as I mentioned, that there are multiple different tools and things you can do as a DevOps engineer. You could be managing your CI/CD pipelines. So a good practice for your CI/CD pipeline would be to ensure that you properly check out your code. You are using the right kind of environment variables. You don't push out any secret directly in your CI/CD pipeline, and you can perhaps also add some checks so that you don't push some unauthorized or non-working code. So adding proper testing suite as part of your CI/CD pipeline. Now, if you're deploying your project, then there are best practices related to how one should deploy your project, because there are different strategies for deployment. There is like this canary deployment, where essentially rather than deploying a new feature to everyone in the industry or everyone in production, you
Mhm.
select a set of users that first receive that new update that you have launched, and they can give you feedback based on that, and you see that, okay, like is it stable enough, and then you release that feature to the next set of users in a future release, right? So you're not shipping the live feature to everyone at once. So this is like called as a canary deployment or a blue green, I think yellow green deployment. Like there are different strategies within deployment as well. So these are the best practices for deployment. Now if you are more of a network engineer slash a person who is mainly dealing with VMs. So you need to follow best security practices over there. You cannot just simply expose your VM to anyone, right? You need to have proper security in place. For example, if it's a private network and you only want certain VMs to be accessible within your company, so
Okay.
you don't have to give it a publicly accessible IP address. You want to be able to limit the number of IP addresses that can actually log into that particular VM, and then add security measures. Then best practices for dealing with security, not security concerns, but scaling concerns. So you need to choose between things like, okay, should I use load balancing? Should I use like spot instances, or I should just go ahead and set up like thousands of VMs, right? Which doesn't make sense. So like depending on the type of role that you're playing as a DevOps engineer, those best practices will probably vary based on the use case. But one thing that will probably be common to every role inside of DevOps is that um, always ensure that as a DevOps practitioner, you properly take into account security, the cost associated with running all of the things that you're doing, because as operational managers for being able to distribute the code, you are responsible for the smooth functioning of the code once it goes live, and ensure that it's managed well. There are no security concerns. Cost optimization is happening when you're deploying your projects, because otherwise if you don't optimize the cost, then you can run into thousands of dollars of unwanted cloud bills. And like, trust me, I have been almost gotten fired from my first ever role because I was not that great with optimizing my costs, and I almost costed my startup $20,000 in a single month in AWS
Wow.
builds. And see, that's natural, and I'm being very honest about it because I don't have anything to hide. Like, these are the common mistakes that happen, right? So it's not just that, hey, today I'll write a Docker file, I will push it into production, and I'll call it a day, right? DevOps is not just about deployment; it's also about different things, right? It's so again, just to kind of re-clarify, it's about deployment, it's about the cost and the management of the resources. It's about monitoring your applications that you are serving, right? So monitoring and ensuring that, okay, if one service goes down, then how quickly you can bring it back up. Like, that's the role of a DevOps engineer. So best practice is to ensure that you follow the core principles of DevOps. Like, we didn't speak about them, but like, there are core principles, so every DevOps engineer should understand them and then be able to apply them in real life. And of course, that would require you to have enough practice, right? Build projects and then try to deploy them, try to use different DevOps tools and use best practices to be able to do that. So for any DevOps engineer, I think like the core principle is to just or best practices to follow those principles of DevOps, because they play a very important role in making sure that a particular application or a software is successful, right, and is scalable as well.
Oh yeah. Wow. Wow. This is eye opening. Not gonna lie though, I never knew that DevOps also includes costs, like thinking about costs. Because I remember the very first time I tried using AWS for a project,
Yeah,
I got the AWS credit, and
yeah.
in less than a month, I exhausted it.
Yeah.
Not gonna lie, but AWS is very tricky, especially if you're a new user. Very, very tricky to use.
So trust me, like, one day, like, what you'll see is that for about 2 months as a DevOps engineer, you are the king of the world. Or, like, what uh, is king a general neutral term? I'm sorry. You're the person of the world.
Yeah.
uh, then, and you're going ahead and building all this great stuff for your company. And the companies, they're happy with you, right? You have just helped them launch a successful product. But after those 2 months, the next probably 3 months would be pretty boring for you, because you might find them to be boring, because every day you will be creating reports for your financial department, of sharing with them why is the, because the financial department will come after you and say that why on earth is our team getting thousands of dollars in costs associated with the DevOps or the cloud, and how can you reduce it?
Really?
So you spend months at a time now trying to, see, okay, what are the services that I can close, talking to the engineering teams and asking them to relax a bit and try to reduce the cost. And your entire goal is now not building the actual DevOps platform, but to just optimize the costs, and which means that
Wow.
uh, you know shutting down the unnecessary services, uh, taking some keen engineering decisions to make certain things probably more cost effective. So yeah, that's like part and parcel of a typical DevOps engineer's life cycle, right? That they will be very much involved with cost discussions, like because there's pressure on the engineering leaders, right? On the engineering
Yeah.
management to be able to bring the cost down, because the financial department will be after them. They see that there's a lot of cost coming from there.
Wow. That I did not know. In my head, I thought that DevOps was all about creating pipelines, deploying, and once that's done, that's done. I
No.
really didn't know of this.
Unfortunately, that's not the case. And again, like, there might be a dedicated person in your DevOps team that just does that, but you could be the
Okay.
person doing both. Again, depends on what team are you part of, how big of a company you're part of. Like, when I was working in my
Yeah.
first startup as a founding engineer, I had to do everything. I had to write the APIs, I had to deploy them, I had to manage the cost, I had to create Excel reports of, or not Excel reports, but I had to like create reports where I was showing my CEO the per monthly bill. And then we had like some really difficult discussions as well, where, as I mentioned, I was almost fired because my CEO was livid that I had spent $20,000 in AWS credits, where we got like limited set of credits. Now luckily, like, AWS waived it off, but that gave me a really important life lesson, that as a DevOps engineer you cannot just simply go ahead and randomly start something. Like, everything needs to have a business decision, right? So I
Okay.
think like these are discussions probably a bit outside of Python, but yeah, I mean, since we are talking about DevOps, like, it's important to understand this as well. Not a lot of people talk about it. This is something that you end up facing when you are working on a live project. Like, if you're working on a
Okay.
simple side project, then you might not experience this. But trust me, like, this is a real problem, and a lot of your days are going to be spending this just doing this, like, optimizing the costs, which means like you're still
Wow.
dealing with most of the DevOps tools, but with the vision that, okay, you want to maintain that same level of scalability, but you want to bring
Yeah.
your cost down by 50%. So
Okay.
that's the challenge for you. So there you now need to think like a proper problem solver and see, okay, how do you perfect your architecture. So
Oh wow.
these are some of
Wow.
the real world problems that you have to deal with.
All right. Wow. Okay, so in a team where we have the front end developer or front end engineer, the back end engineer, and the DevOps engineer. Between the back end engineer and the DevOps engineer, who handles the security of the application or the deployed project?
Yeah, I think it's more of a mix of both. So, from a software engineer perspective, we want to ensure that they follow best practices while writing the actual application code. So, their
Okay.
APIs that they write, they should be properly compliant with best security practices. For example, they should not expose any environment variables. Whenever you're returning a response from an API, that should only include information that's necessary and not leak any information that might not be relevant for the API that you have created. So, of course, like, those are
Okay.
some of the best practices that one will have to follow, right? When you're probably writing your application layer code, you use certain libraries for password hashing. All of those will be done on more of the application layer itself. But then the security of ensuring that, okay, your application that you have deployed is not vulnerable to DDoS attacks, or you're using the right kind of network protocols. All of that
Yeah.
will be more of a DevOps engineer's role, right? So security, I think, happens on both the application layer itself, but then once you productionize your application at that same layer. For example, you might be able to push your application code to a public registry, but for security concerns, you might want to do it on a private registry, right? And then, as I mentioned about CI/CD, so their DevOps engineers need to ensure that they're also not exposing secrets inside of the workflow YAML files itself. They are using proper environment secrets, and then there are a lot of different secret management tools that you can also leverage. For example, if you want to have a layer of authentication, or you want to give fine grained authorization, right? So this is also like one important thing, which is multi-tenancy, that you have the same application, but certain people with certain designations can only access certain parts of the application. So that's multi-tenancy. Or fine-grained access control, where, for example, a customer on Amazon.com can only look at the customer facing set of APIs, whereas
Yeah.
on the UI for a vendor, they're the ones who are probably using Amazon as a way to add all of their inventory, manage that inventory, manage the products, right, and manage the deliveries. So for them, they should only be able to see the vendor view. So managing all this access control again happens on the application layer, where the software programmer will have to write all of that. Or if you look at, okay, there are certain parts of this Kubernetes cluster that can only be accessed by team A, whereas certain parts can only be accessed by team B. So
Yeah.
adding that. And then, for example, in order to ensure that you don't just push some unwanted code into a private registry, a lot of times you have to sign your containers. So similar to how we sign our GitHub commits with, I think, using the .s sign, so hyphen s, which will sign your Git commit. Similarly, you can sign your container images to ensure that to ensure that they have been pushed from a known account, and no one else who might have gotten access to your private registry through some illegal means can push some unwanted or malicious code directly into your pipeline. So that's where you have to leverage good security practices to be able to ensure that your application is secure both from some unwanted attacks, from potential network attacks. So there you are ensuring stability of your network and adding protocols to prevent things like DDoS attack. So yeah, those are the things to consider.
Wow. Wow, this is really, really insightful. And
Mhm.
I didn't want to cut you off initially, but you said something about signing your Git commits.
Yeah. So,
Seriously.
if you have you ever used like signing of GitHub? So, if you look at some of the PRs, there it would have you might have probably seen that in the PR itself it says signed off by. So, just to give an example to everyone, let me
Okay.
open one of the projects. I'll just quickly share my screen again. Okay, so I'll just quickly show one example. So, let's say that I look at this particular example of a pull request. So here you'll see that it says signed commits, right? So
Yeah.
the idea over here is that in order to ensure that only the person who is authorized to push that particular commit, only they are actually committing it. And in that case, it will
Yeah.
be that if you are having a GitHub account, of course, your GitHub account has an email attached to it. So when you sign off a commit, which means that you are the only original author of that particular commit, and no one who might have by some of the other means gotten access to your Git account was trying to push a commit for you. So of course, if someone already has access to both your GitHub account and your email, then of course
Yeah.
you're screwed. Sorry for that language, but like that's bad. But if someone might have gotten access to your GitHub account, but they don't have access to your email account, so with the help of signed commits, you can prevent unauthorized access to pushing unwanted. code, right? So that's like similar to signed commits. So similarly, when I talk about like signed images, right, in order to improve security of your code, you can basically use something called as signed. So I'll just quickly show you. So signing your model kit. So what does signing basically means that um, it it basically means that you are telling you're telling the registry that this is coming from an authorized person's account and not just someone randomly who might have gotten access to your system and they were trying to add some malicious code. This is coming from someone who is authorized and is is basically version, right? Now how we add like a Twitter tick mark, that means that
Yeah,
this
yeah.
person has been authorized. So this is coming from an authorized account, from a verified account, rather than someone who is illegally trying to push something. So signing your commits, for that matter, signing your your container images, like that is also a huge part of ensuring that you have proper security. I didn't use one particular term today, which is called as software supply chain security. So all of the software supply chain security deals with all of that. In fact, like it's again a really important aspect of your software development life cycle, which
Yeah.
deals with
Do
all of
you
the things that
mind
I
sharing this
yes.
article?
Yeah, yeah. So basically, all the things that I mentioned, Sophia, about ensuring that your CI/CD pipelines are always going to be um, they are accurate and they are secure, and then also security of signing off your containers, right? All of that comes under the supply chain security. So this is an important aspect of every single DevOps team that today is dealing with production grade application. So,
Oh, wow.
so just wanted to
This,
basically touch upon that. Hmm.
yeah, wow. This is really, really, really insightful. Now,
Yeah,
okay, in okay, just so I really understand what you just explained, multi-tenancy is similarly to role-based access
yeah,
control, where
exactly.
only people that have access to a particular um, service can
Mhm.
access it, and people that don't have access are restricted.
Yeah. And you can apply this with the help of DevOps as well, right? So
Yeah.
there's this another project, and as I told you, I can go on and on about all of this, but it's important to probably discuss all of this because security, like people generally don't talk about it. So I'll highly
Yeah.
recommend that you can probably have a stream separately about security in DevOps because that's
Oh
like
yes, I would
one.
love that.
Yeah. So this is like one example where if you want to add that relationship based access and in a cloud environment, then this OpenFGA, this is another open source tool that DevOps engineers will most likely use.
Open FJ. What is Open FJ
OpenFGA.
mostly about?
So
FGA, yeah.
yeah, that's for authorization and being able to like add granular control over your application, that okay, what parts of the application can only be accessible by a certain number of folks, or you can technically also apply similar principles on infrastructure, right? Because like let's say you're having a VM now, a VM will have different parts of the code. You don't want, like let's say, the front end engineers to be able to access the back end code, or you don't want the back end engineers to probably access the designer's code, right? So you can add that accessibility layer on the infrastructure itself, so that if a person tries to access, and so that is why, like if you look at the Kubernetes, right? Kubernetes has something called as namespaces. So namespaces basically provide this level of relation, this role based access control in a way by default, that there could
Okay.
be a namespace in Kubernetes with backend. There could be a namespace in Kubernetes with AI. So like you're trying to run an AI workload, there are only parts of your cluster that should be accessible to the ML team, and there should be only one software cluster that should be accessible to the backend engineering team. So again, that fine-grained uh, authorization and access control is something that both development teams and also DevOps teams have to deal with.
Oh, I see, I see, I see.
Yeah.
Wow, this is such an eye opener. So
Mhm.
not only did I learn that DevOps is not just all about deploying pipelines, they also have to think about costs. They
Yeah.
also have to work with the
Mhm.
software engineering team
Yeah. Yeah.
and the finance team, and
Exactly.
they also have to
Mhm.
think of security as well.
Yeah. Absolutely.
All right. So I think we will be ending the stream in few minutes.
Yeah.
So just a few more questions. So what is a fun trend that you are seeing in the DevOps space right now?
What is the sorry? What is the question again?
Okay, what is a fun trend? Like,
Okay, fun
what's a
trend.
trend that you are seeing? Yeah,
Okay. I can probably first talk about the industry trend itself.
yeah.
So in core DevOps, I think observability is becoming a very, very important aspect of DevOps. So any person who is learning DevOps today should 100% learn about observability, because as applications are becoming more complex, understanding how your API's response takes place, how you can improve them, if there are some errors that you're getting in your application code, how you can resolve all of them. Like that's where you need to have a very robust system. And to in order to have a robust system, you need to have robust monitoring of your application at all times. So monitoring not just the latency, the responses that get generated, if there are errors, how quickly you're able to identify the root cause of that error, right? So observability is the number one trend right now. And the second one is, we discussed this before the start of the stream, which is MLOps, which is machine learning operations, right? So far we were talking about DevOps, right? Which is like, okay, development. But today, as machine learning systems are growing in adoption, and one of the biggest technical challenges that these days DevOps teams face is that, yes, you can think of machine learning as similar to software. There are not
Okay.
like a lot of drastic differences, but the biggest differences comes on the fact that the infrastructure requirements for running AI models is vastly different in comparison to your standard software, because most standard software you can use CPU, but most of the core AI workloads require you to have, if not one GPU, you might require multiple sets of GPUs. So GPU management is not something that a traditional DevOps engineer might actually learn. But as a machine learning engineer or a ML ops engineer, you're learning about certain frameworks and best practices where you have to basically adopt, or you have to shift your tactics of DevOps ever so slightly. It doesn't mean that we are reinventing the wheel when it comes to ML ops, but perhaps this can be a discussion for a separate stream. But what I just wanted to
Yeah.
say is that, because machine learning, because Python is very much centric to machine learning, which also means that Python is probably the second go-to language for dealing with MLOps. So there are a lot of different open source tools like uh, you know um, Kubeflow or perhaps MLflow. These allow you to deploy your machine learning models, and I'm not just talking about like LLMs, but even standardized machine learning models that have been there for like the last 10-15 years, and then deploy them on a container. So I showed you an example of a Python sentiment analysis app, which I was containerizing, but that was like a very simple app. But
Yeah.
for applications that might have multiple AI models running in sequence, you need to like have dedicated workflows. So all of those can be defined again in Python. We didn't dive deep into the MLOps side of things, but as an MLOps engineer, you're most likely going to be using a lot of Python, especially for the DevOps side of things as well. Um, but of course, like outside of Python, you mostly like deal with Golang, YAML, Terraform, and like shell scripting. All of those are there. Golang is also like another important one that you should probably explore if you want to like really
Okay.
be a good DevOps engineer. Like you should be good at Golang, because a lot of things,
Golang.
yeah, go again, like that's probably a bit out of scope of this particular session, but Golang is another good one. But like if any viewer is right now like specifically focused on machine learning, then MLOps is like a really nice job that you can get. Like these are high paying jobs, but then they require you have to have knowledge of both machine learning and DevOps, and both of them are like
Okay.
very vast in themselves, right? So
Yeah.
but they are very high paying and they are extremely relevant jobs right now, because every company wants to have a good MLOps engineer to be able to deploy your machine learning models at scale and in a cost effective manner.
I see. I see. So does that mean that there's a possibility for someone to transit from DevOps to MLOps?
I think like transitioning is probably not the right term, because I would probably say that similar to how we say that, okay, AI is this big picture, right? And then like machine learning
Okay.
is a subset of AI. So I would probably say that MLOps in ways is a subset of DevOps, not completely necessarily, but it's applying those same set of practices for DevOps, but for highly specialized machine learning systems. So, which also means that a lot of the basic principles are still the same, but you have to change certain things based on machine learning workloads, right? And whether it's like using the right kind of tooling for supporting machine learning workloads. So that's why like I spoke about this particular project called as GitOps, which is basically
Okay.
an AI/ML DevOps tool. So the entire idea for GitOps specifically, and the reason why you might want to invest time in something like GitOps, and let me again quickly share my screen
All right.
over here for you. So I'll just go and I'll probably just end with talking a bit briefly about GitOps. So the idea over here is that we're talking about AI, and one of the complexities of AI is the fact that most of the times where a machine learning model is being written is in a traditional Jupyter notebook. And
Yeah.
now if you think about productionization of a Jupyter notebook is not very easy. These have multiple cells, and like a lot of experimentation is going on there. So if you just imagine that the data scientists, they handed over their Jupyter notebook to a DevOps engineer, so the DevOps engineer might actually just scratch their head all the time and trying to figure out how can they have absolutely any use of this Jupyter notebook, which in a lot of cases it's of no use, because what the DevOps engineer expects is, okay, there will be the model weights, there will be some application code that you have written for your machine learning model, which we'll have to deploy as a microservice perhaps. So all of those complexities make it very difficult to transition, and also makes it very difficult to apply CI/CD to automatically getting newer versions of your machine learning model, right? So like with Git, it's very easy. You can just simply do a Git pull, Git push for any new changes, right? Git stash, and you can very easily push it and have multiple versions of your software. But having to deal with multiple versions of your AI project, so that is why like GitOps is this missing link in that AI pipeline. So if you are trying to build like a robust CI/CD for AI, with the current set of tools, it can become very complex because of having to deal with
I
multiple types
see.
of tools. GitOps brings all of that together with the help of, as I mentioned earlier, with the help of Model Kit, because now the same Model Kit is being able to package everything that you need to have in a AI project under a single container like structure called as model kit, which is also OCI compliant, which means that you don't have to develop any new tooling to support AI workloads. It will basically work out of the box with any other AI tool that you can, or any other DevOps tool that you might want to use. So whether it's like code bases or trying to deploy it anywhere, it will just go ahead and deploy your model kit. So you can basically also deploy your model kit on container services, whether it's on Kubernetes or it's on containers. So like that's one of the benefits of building platforms that support AI workloads, but they still follow the same principles of a traditional DevOps architecture. Like that's what GitOps is trying to do. It is using those same core principles of uh, DevOps, but applying them to AIML projects. So like that's the main synopsis. So like when I said that MLOps, like does that mean you're transitioning? You're not probably transitioning. You're just learning new skill set as a DevOps engineer to be able to work with AI workloads, because AI systems, they bring their own set of complexities with them. So being able to identify them and then applying them is what is like in the core crux of like MLOps.
Wow. Wow. This is really insightful. Really
Absolutely.
insightful. Okay, so we will be ending the stream with one last question.
Yeah.
Hi, Code Gimmick.
Hi.
Okay, so yeah, so my question is, what is the coolest trick that you've done with Python in DevOps?
Okay. That's a interesting question. I think for me it was just migrating a database. So I still remember I had to migrate from a large amount of data from AWS DynamoDB, which is like a, I would say, like a JSON structure based database, to MongoDB. So I had to
Okay.
do that live translation. And again, if I would have probably done it manually, it would have taken hours and hours at a time. So I just simply developed a Python script that uses the Boto 3 library, which allows you to manage your AWS resources. And then, like, there are dedicated DynamoDB clients available for you to use, that you can use in Python, and that just did the work for me in less than probably 30 minutes. So I think,
Wow.
as I mentioned, that if you are a DevOps engineer, one hack in order to really just rise up in the chain of being a really effective DevOps engineer is to just learn programming. And Python goes a long way, because every day, because you're like, a lot of times it's not that this is a set problem. These are the small problems that you might come across in your day-to-day work, which if you try to solve manually might just take a lot more time as compared to using automation to be able to resolve that particular issue. So that's where, like, the hint or the trick is to learn enough Python so that you can make yourself more productive. And now you can, of course, use like Chat GPT or Pieces, right? We didn't speak about Pieces. You can use
Yeah.
Pieces. In fact, like, I'll recommend you can share this particular video. So back when I was with Pieces, I had created this particular video on Civo, like, which is one of the Kubernetes providers. I had shared this particular video on how you can use Pieces for deployment. Of AI workloads specifically. So, like, the funny part is that it was around, pretty much centered around AI. So I'll make sure to share this particular live stream with everyone.
All right.
So here I show how you can use like Pieces, or I mean, it's not just Pieces, but you can use any other AI LLM tool, right? Like Pieces is one example, and a free example, a great example to be able to manage for that for you. So yeah.
Wow. This was very, very, very insightful. And yes, we did forget to mention pieces. So for anyone that really don't know much about pieces, it's an AI assistant that's okay. I think you're sharing your
And as
screen.
like I have been, doing one thing, I can probably also show one more thing. Like I can
Oh
quickly
yeah,
share
sure.
again, if you don't mind. Perhaps this might be a good kind of a takeaway. So, for instance, like I had Pieces on right now. So, for example, I could have just asked it, okay, um, can you share the code sample for GitOps that I can use with the Python client in order to create a new Git file. So can you share a Python code sample to create a new Git file? Let's see, because I have the live, I have the live, what is it called? The LTS. Right?
The live yes, yes, yes. I have that turned on to on my end, and that really helped me last year when I left my laptop for a while. I came back and I was a bit confused on where to continue, and the live, yes, the live
Mhm. Live
context.
context,
Oh,
live context,
is
because
it
they
live
changed the name from.
context? Yes.
So the live context, and like, see, like, this is a great example, right? I can, um and then, for example, I can ask it that, okay, uh can you create a Docker file for a simple for a simple fast API project. So, and then you can ask it questions, because a lot of times, like for DevOps, we have to deal with very minute details, and sometimes doing error handling can be a bit tricky when having to deal with DevOps. So I think like AI tools can really help you just fix them very quickly rather than Googling. If you're able to provide context of your entire repository, I think making it very super simple for you to be able to look at the logs and be able to understand like what's the error and how you can fix it. These tools like really help manage all of that. So that's what I
Yeah,
traditionally
yeah.
use it for.
And fun fact or not so fun fact, I actually used this to ask question on how to set up this live stream. So I
Okay.
was
Yeah.
yeah, yeah, yeah. I okay, I think it helped me come up with the topic, and
Hmm.
helped me come up with how the live stream would be. In fact, this entire Python hour on my YouTube channel, I
Yeah.
used PC's AI to come up with how to brand it, how to go about the live chat, and
Hmm.
topics to focus on. So yeah, this AI assistants, they're incredible tools that I genuinely think that everyone, both people that code and people that don't code, as far as we work in tech,
Yeah.
this is a useful tool for anyone and literally everyone.
Absolutely.
Right. Okay, so since we have come to the end of our live chat, well, I really, 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 really enjoyed this. And if you're up for it, I would still love to have another one to focus on the security of DevOps.
Yeah, of course, and I think I would probably recommend someone else
Oh
to
yeah,
do
sure, sure, sure.
security. I think like I wouldn't do complete justice, because security is one thing that, okay, I have high level knowledge, right? But I'll not call myself as an expert. Of course, I can still share some of the best practices, but I can definitely recommend some folks who can probably talk much more deeper into the security aspect, because of course it's important. But I'd love to come up for MLOps, because that's my gig, right? I
Oh,
can.
really? Wow, definitely. Right. So, for everyone that has watched from the beginning till the end, thank you very much for joining us on this live chat. Um, and we hope to see Shive here again, hopefully for ML Ops. So, fingers crossed.
Absolutely.
And yeah, and do well to subscribe to the channel, so that when next I go live, you can be notified. So
Yeah.
I usually do this live chats focused on Python, because on my channel right now I'm focused on Python. So
Mhm.
I try to come up with questions that Python developers, be it Python in software engineering, Python in machine learning, Python in data science, as far as it's Python related. I try as much as possible to have live
Yeah.
guests, to have guests cover it up
Yeah.
here live with me.
Yeah. Thank you so much.
And
Uh, I don't know how to pronounce it. Is it Uncle Big Bay or?
yes, yes,
Oh yeah. So thank you so much for
is
sticking
actually Uncle
around.
Bibi. Yeah, same here.
They
All
have been
right,
listening very
so
patiently.
yes, he has, and funny enough, he was the very first person to join the stream.
Oh,
He
okay. Okay.
joined around 10 minutes before
Wow.
we went live.
That's a
So
lot of
Salmon, thank
dedication.
you.
Thank you. Really appreciate that.
Yeah. All right, so we are ending